Hi folks, welcome back to my channel Learn Statistics with Mustafa. Today's lesson we're going to talk about widely used test alternative to classical test, which is repeated measures test or repeated measures ANOVA. In previous video we talked about one-way, two-way, three-way ANOVA. All those tests assume normality of distribution, homogeneity of variance, and independence of observations. When we have a situation where the assumption of independence of observations is violated, in this case, instead to use the ANOVA, classic ANOVA, we must use the alternative one, which refers to the repeated measures ANOVA, also called within factor or subjects ANOVA. After loading these packages, and especially Datarium, which contains many of data set, and applying this function view to explore this dataset self-esteem. So the term of within factors ANOVA or within subjects ANOVA refers that each individual's measured more than once on dependent variable during 3 points time during a diet program. So this is the results of or this value corresponds to the self-esteem score. So the goal of this repeated measures ANOVA here to assess if or whether the repeated measure or whether score of self-esteem improved. So this is all of our individuals, from 1 to 10. So each individuals have three values refers to score of self-esteem measured between, for example, from time 1 to time 3. So the time here represents the independent variable or the exponential variable, and the results of each individuals from 1 to 10 between or during this 3 points time refers to the dependent variable dv, or the outcome or the response of variable. So first this one of test, this statistical test or repeated measures test has two main assumptions. The first one is the normality of distribution, but before applying the test of Shapiro-Wilk to check the normality of distribution, we should transform this data into newly data that corresponds to one variable points to three group of time, and the second variable relates to a dependent variable, which refers to the values of score esteem. Following this comment, self-esteem is equal to self also esteem percent more than percent, using the function gather k equal between double quotation mark, and for example write the independent variable or factor or within subjects factor which is time, comma, value equal. Here we, for example, might write score corresponds to the score of self-esteem after diet, for example, program, and T1, T2, and T3. Very well. So our data set become the self-esteem view data set. So this is the newly form of our data set. The ED refers or numbered from 1 to 10, which represent each individual. So the time is the independent or the exponential variable, contains three groups: time 1, time 2, time 3, and these are the results or value of the score, self-esteem score. So in this case, the repeated measures ANOVA is used to check whether the score is improved or not. So following this command to check the normality of distribution, we should write self-esteem equal to, or percent more than percent, group by, and select the independent variable or within subject variable, which is time, percent more than percent, and select and write Shapiro underscore test from statics package, and write score, which refers to dependent variable. In this case, our three groups follow a normal distribution. So the first assumption of the normality of distribution is met. The second one refers to sphericity assumption, or the sphericity of the mock least test, also called mock least test, is automatically applied when we use ANOVA underscore test from our statics package. When we have a p-value of sphericity, significant p-value of sphericity, in this case, a correction, two correction, either greenhouse case correction or Hohenfeld correction is applied when the case of significant, applied automatically when we have p-value significant. So let's get started and computing the ANOVA, or the within ANOVA, or the within esteem percent more than percent, and write ANOVA test. dv refers to dependent variable. Here is score. Width is refers to the ID. This is the ID. Is numbered from 1 to 10, refers to each individuals. We have only 10 individuals with repeated measures. And within refers to within factor, which is time. So in this case, our p-value is significant, equal to 2.01 multiplied by 10 raised to the power minus 8, which refers that the p-value is significant. So there is influence, or significant influence of time on the score of self-esteem. So GES indicate the effect size. We can interpret this value as this way: 82% of the variance of score of the variance of dependent variable is depend on the time, or on the group of time. So when we obtained p-value, significant p-value from repeated measures ANOVA using this function ANOVA underscore test from package statics package, we could not stop there. Why? Because the ANOVA repeated measures ANOVA, or any kind of ANOVA, tells us only that at least one group is significantly different from the others, but it does not tell us which groups are different. So to identify the specific differences, we need to perform a post-hoc test, which refers to a pairwise t-test, usually used to between, for example, the time, between time 1 versus time 2, time 1 versus time 3, and also the case of time 2 versus time 3. So using the pairwise t-test and the Bonferroni adjustment, following this command self-esteem to perform a pairwise t-test, pairwise t-test underscore test. Yes. And we should put here the score, which refers to dependent variable score tilde time, and select value adjusted value method between double quotation mark Bonferroni. So The output of the pairwise t-test underscore t underscore test from the package statics indicates that the all group here, all groups show a significant difference. So, for example, time 1, group 1, time 1 versus time 2, there is a difference significant in mean of self-esteem score. The same case of time 1 versus time 3, also significant difference here. The results of p-value is less than 0.05, and the time 2 versus time 3, again a significant difference. So this example, each group point or each time group is statistically different from the others, which suggests that the self-esteem scored the score of self-esteem changed consistently across all 3 measurements. So after computing the ANOVA here, ANOVA repeated measures ANOVA, also called within subjects factors and pairwise t-test, we might want to, for example, visualize these results and this in a figure. First, we should name this comment. For example, this way we can easily use it later. For example, test 1 equal to the output of test of repeated measures ANOVA. For example, we can test it using this following. This refers to the output of repeated measures ANOVA, and test, for example, 2 equal to the pairwise t-test. Also, we need to add a position of characteristics using in the figure, like this command test 2 equal to add dot no xy position. X refers to independent variable, which is time. I missed to add this test label %model %. Very well. So after this, we might want to use the ggplot function, self-esteem, aesthetic graphical, x equal to the independent variable, which is time, y is refers to score, and color the time, plus boxplot, gm boxplot, click to 1. This results explained or shows, or this figure shows the distribution of each group of time using the score of self-esteem. If we want to add the results of ANOVA, repeated measures ANOVA, or called also within subjects ANOVA, we can only add this comment, labs, subtitle, get underscore test label, underscore test label, and write test 1 detailed equal to true. This is the output of the results of repeated measures ANOVA, indicate a significant difference. And if we want to add which specific test using to analyze or assess the pairwise comparisons, which is pairwise t-test, we can add this one, caption equal to get pwc label, and write test 2. And if you want to, for example, add the characteristics that explain which specific group have difference significant between their means, we need only to add this one. If we want to add the characteristics to show which specifically the group, all the groups which have a significant difference between their mean of score of self-esteem, we need only to add this comment stat p-value manual and write test 2. So this asterisk, for example this and this, represents a significant difference between groups. For example, between group time 1 versus time 2, that group has significant difference in the mean of self-esteem score. Also, the same case between time 1 versus time 3, and time 3 versus time 2 versus time 3. So that's it for this video. If you have any suggestions, comments, or questions, please leave them below. I will also copy this comment and leave them in the description or the comments below. Thank you for watching and take care of yourself, and peace out.